This is Xijia from University of Michigan. I'm also pursuing a dual degree in Shanghai Jiao Tong University. It's my pleasure to be one of the 2023 RISC Scholars. This summer, I'm working in the Advanced Agent Robotics Technology Lab at the Robotics Institute in Carnegie Mellon University. Before I proceed, I'd like to express my sincere thanks to Professor Sikra, Sophie, Joe, and Simon. Their guidance and support mean a lot to me. My project is language-explainable neural networks via knowledge distillation and feature extraction. It is based on a motivation to explain neural networks. Most networks today are black box models functioning in a manner that humans cannot directly comprehend. Although there have been some efforts on solving the problem of model explanation, existing works address this issue only to a functional level, mostly focusing on the construction of a theoretically explainable network. As humans, we need a more powerful communication method to understand the decisions of a network. And the most intuitive information for a human to digest is, of course, natural language. This is an overview of our proposed method, which basically involves 3 steps: knowledge distillation, feature extraction, and large language model query. We first follow the standard method of model distillation and replace an existing network with a decision tree to make it interpretable in structure. And from this structure, we acquire a decision path corresponding to the input query and look at which nodes the tree actually goes through for a decision. This gives us a set of concepts that counts towards the result. We bridge the last step between set of concepts and language by querying large language models to generate human understandable text messages. Our method falls into 2 constraints. First, the target network should not have a significant decrease in performance after distillation. Second, the task settings must consist of interpretable features so that feature extraction can lead to a set of interpretable concepts. We resolve the second constraint by the task beds we choose: bird identification through concept learning on the CUP dataset, and a multi-agent reinforcement learning environment on urban search and rescue. To address first constraint, here's our results from model distillation, showing a considerable performance in both datasets. Both distilled policies for CUP and USAR do not decrease significantly in performance. This allows us to proceed the method. And here are some examples of the results we get. This one explains why the network classifies the bird as a Canada warbler. As we can see, it correctly states the observation that is extracted from the feature extraction process, including its black eye color, perching-like shape, and multicolored breast patterns. It addresses the lack of specific traits as well, indicating that they also count towards the network's decision. And same to the fish crowd example, where the network correctly explains the extracted set of concepts that the bird possess or not possess to make its decision. And the following are explanations of urban search and rescue policies. This one explanation of a MEDIC policy, which is heuristic-based. As shown in this map, the MEDIC is in room 1-3, and the network tells it to go north. By distillation, feature extraction, and LLM prompting, we acquire the explanation as shown. And in addition, this one is explanation of the engineer policy. It addresses the question of why the engineer moves from room 01 to 00 in explanation. So far, our method has shown promising results, but we still need a metric to quantify its performance. In future work, a human study will be conducted to show our hypothesis. That's all. Thank you for listening, and feel free to follow my work to see how this goes.